So on number 1, first thing I notice about this problem is that in between these two rational expressions, these two fractions, there is division. How do we handle division with fractions?
Flip the second fraction.
Flip the second fraction. Is that the only thing? Change the sign. So we're going to keep change flip here. X squared plus x minus 6 over 6x minus 3, and then we're going to change this to multiplication, and we are going to flip this fraction. So 2x squared minus 7x plus 3 goes up on top, and x minus 2 flips down to the bottom. So after we do keep change flip, what should be my next thing to do?
Look for GCF.
Look for GCFs. Are there any GCFs anywhere?
Only one at the denominator of the first fraction.
Denominator of the first fraction. What is our GCF down here?
3.
GCF of 3. Let me scoot all this up just a little bit. Okay. So I have x squared plus x minus 6 over, I'm going to take 3 out. What would I have remaining then? 2x minus 1. This stays multiplication. 2x squared minus 7x plus 3 over x minus 2. All right, we pulled out GCFs. What do I do now?
The x things.
Do the x's. What am I looking at to do the x's with? Factoring, yes, we're going to use it to factor. So what am I trying to factor? Which polynomials? The ones on top, the two numerators. We've got this one right here and this one over here. So let's do the one that I circled in purple first. Can I use my shortcut on that one?
Yes.
How do we know? A is 1. Okay, so I need two numbers that multiply to give me -6, but add to +1.
-2 and 3.
-2, +3. So what will the numerator be when I rewrite it? X minus 2, x plus 3, over, and we have that GCF of 3 out there, and 2x minus 1, times, I know the denominator of this second fraction isn't going to change, it doesn't factor. How do I know by looking at it that the denominator of the second fraction doesn't factor? No exponents. There's no GCF with it, we already looked for those. And then there's no x squareds. This is a linear factor. It does not factor further. All right, so now we're going to do that numerator. Is there a GCF on the one that I circled in blue? No GCF there. Okay. So I'm going to do my x. I'm going to multiply a and c together. Will I be allowed to use my shortcut here?
No.
No. Why not?
2.
A is 2, and we already looked for GCFs. So a times c is 6. My b value, though, is -7. What's going to multiply to +6? -6 and -1. Nice work. -6, -1. This is what I'm going to have to put inside my area model. A value goes in the upper left, c goes in the lower right. 2x squared and 3. We're going to take the two numbers that we just found, that -6 and -1. They both get what back on them when I put them in the box? They get an x. Why? Why do we put an x on them?
The x is on the top left.
The x is on the top left.
So when it's an x squared, so you'd have to put an x on the top and to the left of that box, which then would go to the other boxes thereby.
I like that explanation. That is correct. How do I know by looking at just this? I like Jimmy's explanation, but how do I know by looking at just this that I need x's in these two boxes?
Because the b is x.
Yeah, b has this -7x. Remember, what I put in my area model is this, just written slightly, like it's arranged slightly differently. So I have -1x, negative 6x, and then we're going to look for GCFs now. What can I take out of 2x squared and negative 6x?
X.
2x. Nice work. Yeah, if you flipped where your negative 1 and negative 6 are, your top and side are going to be flipped from mine, but you're going to have the same two factors because it doesn't matter which boxes you put them in. What can I take out of the bottom? Negative 1x and 3.
Negative 1.
Negative 1. How did you know it was a negative 1 and not a positive 1?
There's a negative in the box.
Negative in the box. It's touching this, so we're pulling that out as part of our GCF there. So 2x minus 1. And then we're going to go vertically. 2x squared and negative 1x.
Now normal x.
Now normal x. Just a 1x there. Good morning, Evan. Thank you. What about negative 6x and 3?
And negative 3.
Negative 3. Again, we're pulling out this negative right here. So x minus 3. All right, so we factored. What do I do now? The directions said simplify. What do they mean?
You have to cancel out the denominators and numerators that match up with each other.
Cancel out the denominators and numerators that match up with each other, such as
2x
x minus 2, x minus 2, 2x minus 1. Can I cancel anything else out? No, so we're going to write down what we've got left over. What do I still have in my numerator?
x plus 3, x minus 3.
X plus 3, x minus 3. And do we have anything left in the denominator?
3.
3.
And if you want to, you can rewrite it into perfect square form.
Yes. You could take that numerator if you felt so inclined. You could double distribute, because this is what happens at the end of a difference of two squares. These are the factors that we get from that. So you could write that numerator as x squared minus 9. You don't have to. I'm perfectly fine if you leave it right here. All right, so that finishes out number 1. Does anybody have any questions for me about number 1? All right, we're going to go to number 2 then. Do I need to do keep, change, flip on number 2? Why not? Because it is addition, it's not division. So if I'm going to add these two fractions together, what do I need? Need a common denominator. Do those denominators, careful here, do those denominators have any factors in common right now? Factors, no. I like that. You caught yourself. You said, yes, x. Wait, no, it needs to be a factor. Factor is the whole thing. So if you see a plus or minus sign with it, it has to include that whole thing for it to be a factor. So right now they don't have anything in common. So I'm going to need to multiply my first fraction by x plus 2, top and bottom.
And x minus 4 on the other side.
And x minus 4 on the other side. You're absolutely correct. Okay. So my two fractions then, I would have 2x times x plus 2 over x plus 2, x minus 4. Plus, and then over here we have 5 that is getting multiplied to x minus 4 over x plus 2, x minus 4. Do they have the same denominator? Yes. There's a lot of people that I saw get to this point on the test that we had over this before spring break, and I understand why, but be careful here. They got to this point and they're like, oh, same factor, top and bottom. X plus 2, x plus 2. I'm going to cancel that out. And they did the same thing over here. X minus 4, x minus 4. I'm going to cancel it out. Takes you right back to where you started. That's right. And then you don't have that common denominator anymore. I'm super glad you guys are looking for things that cancel, but we don't want to undo what we just did. Remember, why we did that was to get that common denominator so that we could put them together. Once we've got them together and we've done the addition, then we can start looking for reducing, but we want to wait until the end to do that. All right, so right here, I'm going to distribute 2x to both of these pieces, and I'm going to distribute this 5 to both pieces over here, and then we're going to add all that together. Since I have the same denominator, can I write this as just a single fraction now?
Yes.
Yes. And I'm adding these pieces together so I don't have to worry about distributing a negative. All right, so I'm going to have 2x squared plus 4x, and then I'm distributing a positive 5, so plus 5x minus 20, all over my common denominator of x plus 2, x minus 4. My preference, by the way, is that you guys leave that denominator in its factored form all the way to the end. Some people decided to double distribute at the end. I'm not going to take off points if you do it correctly, but it's unnecessary, it's time consuming, and it also means, I'm sorry, ladies, it also means that it's easy to miss if something does reduce. So please leave it in factored form. Am I all done? I've added things together. Combine like terms. So I'm going to combine 4x and 5x, and that's going to give me what? 9x. 2x squared plus 9x. We should certainly try. Do we have a GCF? Why did you suggest doing the x in the box? I like it. That's what I want you looking for at this point. We need to see if anything cancels. All right, so I'm going to draw my x. We won't be allowed to use the shortcut here because a is not 1 and we don't have a GCF. So I'm going to multiply 2 and negative 20. So I need two numbers that multiply to give me negative 40, but add to 9. Things that multiply, what multiplies to 40? 1 and 40. There's no way I can use those to get 9, right? 2 and 20. 2 and 20? Yes, 2 and 20. Is there any way I can take 2 and 20 and put them together and get 9? 4 and 10? 8 and 5. Can I use 8 and 5 and get 9? So does this factor? Will this reduce then? Then I'm done. Fully simplified. Nice work. Before we go on with the rest of our lesson for today, I want to point out on number 2. Remember yesterday when we were doing those story problems and we were setting up the rates? Joe can paint the house, one house in 5 hours, and then Sam can paint one house in 3 hours. And we wrote these rates, these ratios for each person, and we found out how long it would take them to do it together. So we added them, we set it equal to another ratio. After we set up those proportions, we were able to get rid of our fractions completely. What symbol did we have yesterday as part of our work that allowed us to get rid of those denominators that I don't have here in number 2? An equal sign. With an equal sign, I have the ability to clear out any fractions, because if you do it to one side, you can do it to the other side. So I can multiply by a denominator, because division and multiplication cancel each other out. But if I don't have another side, I can't do that. So if there's no equal sign, you can't get rid of your denominators. You're stuck with working with fractions. I want you guys to go to page 222. Are you okay? Okay. Go to page 222. What do you see right after that first fraction?
An equal sign.
An equal sign. I like this, because if I see an equal sign there, I have the ability to get rid of my fractions. If I don't see the equal sign, I can't. All right. Looking at my denominators, are they the same? Do they have any factors in common? No. So yesterday what we did is, once we checked those denominators, we set up our LCD. Do you guys remember doing that? And that's what we're going to multiply by. We're going to multiply each term here to get rid of those fractions. What things should be included in my LCD? X minus 2 should be included, and x plus 1. Are there any other denominators? No other denominators here. So that's what I'm going to multiply every term by. Not just every fraction. How many fractions do I have here? 2. How many terms do I have? 3 terms total. 2 of them are fractions, 1 of them is not. But I have to multiply all 3 pieces by my LCD. So I'm going to multiply here, x minus 2, x plus 1. I'm going to multiply here, x minus 2, x plus 1. It's getting messier, sorry. And then I'm going to multiply this one, x minus 2, x plus 1. All 3 pieces. So far, so good? When you look at just the first rational term here, is there anything that's going to cancel? X minus 2s are going to cancel. So what do I have left over? I have 2 and I have an x plus 1 left over. So I'm going to write that down. 2 and the x plus 1 is inside parentheses, so I'm going to leave it like that. Then I'm going to bring down my equal sign. In the second rational term, will anything cancel? X plus 1s are going to cancel. What do I have remaining? X minus 2 and the 4. So I have 4 and I have x minus 2 inside parentheses here. I'm going to bring down that plus sign. Will anything cancel in my third term? No. So I've got both pieces here, plus that 1 out in front. But if I multiply something by 1, what happens? Stays the same. If that was a number anything other than 1, I'd have to recopy it. But since it's a 1, I can kind of just ignore it. So I have x minus 2 and x plus 1. What should I do right here? Distribute. What operation are we doing when we distribute? Multiplication. Nice work. What should I do after the equal sign? Same thing. We're going to distribute here. So 4x minus 8. And then I get to the back. Double distribute. I love it. Yes. I'm going to take the x and distribute it to both pieces first. So that'd be plus x squared minus 1x. And then I'm going to distribute the negative 2 to both pieces. So minus 2x minus 2. Combine like, so what are the like terms that I need to be combining? All right, so I heard 4x, and then negative 1x and negative 2x, right? Negative 8 and negative 2. All right, so I'm going to recopy the left-hand side for right now. 2x plus 2 equals, is there a like term for the x squared? Nope, so I'm just going to write it down. X squared. Just x, because I have 4 minus 1 minus 2 more leaves me with just 1x. So plus 1x. And then you said how much? Minus 10. I want you to focus on this right here. What'd you say? We're going to have to do the x, but before I can do the x, because of this equal sign, what needs to be on the other side of the equal sign?
X times positive 1.
Yes, thank you. Thank you, guys. Okay, so I made a mistake here, so that was adding. So this should actually be what, a 5, 4, 3x? Okay, thank you. Thank you, Belzy, for catching that. The dangers of zooming in on my screen here. Okay, Soraya, back to your comment now. We do want to do the x. We want to factor this. I have this over here. What does this need to be? Not just x. If I'm going to factor this, it needs to be equal to 0. I need a 0 over here. So whenever you see this x squared, this is quadratic. And when there's an equal sign with a quadratic, we have to set it equal to 0. So how am I going to make this cancel if I want to get a 0 over here? Subtract. So I'm going to minus 2x from both sides. That cancels. Do I have 0 over there yet? No. I have a 2 still. How do I get rid of the 2? Minus 2 from both sides. Now do I have a 0 over on the left? Yes. Okay, so I have a 0, and then I have x squared. Now I have plus 1x. Thank you guys so much for catching that, because otherwise we would have been really thrown off right here. When I do the x here, will I be able to use the shortcut? How do you know? A is 1. Is there a GCF? Nope. A times C. I need two numbers that are going to multiply together to give me negative 12, but add to give me a positive 1. Negative 3 and positive 4. So what will this be in its factored form? X minus 3 and x plus 4. What do I do with each of those factors? Set it equal to 0. Absolutely correct. X minus 3 equals 0. X plus 4 equals 0. Over here with x minus 3 equals 0. What next? Plus 3 on both sides. So I get x equals 3. And with x plus 4?
Minus 4 on both sides.
Subtract 4 on both sides. Nice work. So I get x equals negative 4. Before I can be totally done, think back to when we first started graphing the parent function. What denominator is not possible when we have fractions? 0. I need to make sure that none of my answers make any of the original denominators 0. So let's substitute. We have to check to make sure that the denominators are not 0. What was the first denominator? X minus 2. So if I put 3 in here, what is 3 minus 2? 1. That's okay. I just don't want a 0. And then I'm going to put negative 4 in. Negative 4 minus 2?
Negative 6.
Negative 6. We're good with that also. As long as it's not a 0, I'm happy. Was that the only denominator?
X plus 1.
X plus 1 was also a denominator. I have to check that also with both of the x's that we found. So if I do 3 plus 1, 4. We're good with that. What about negative 4 plus 1?
Negative 3.
Negative 3. We're good. All my answers work.
And thus not extraneous.
None of them are extraneous. You're correct. If we have to throw one out, we would say that's an extraneous answer, an extraneous solution. All right, let's try another one together. Look at number 2. What do you notice about the first denominator? It's a difference of perfect squares, yes. So what should we do with that right at the beginning? Yep. We're going to factor this to be x plus 3 and x minus 3. When I'm going to find my LCD, I only want to include factors once, because we've asked that each time. Is this a factor or a multiple of what I've got here? Because I don't want to include pieces that I don't need. It makes more work for me. What is my LCD going to be? X plus 3, x minus 3. That's all part of the first denominator, right? When I go and I look at the next denominator, do I already have this factor as part of my LCD? Yeah, x plus 3 is already there. I don't need to write it down again. What about x minus 3? It's already there. I don't need to write it down again. So I don't need to multiply by it twice, just once. So I'm going to multiply each of these fractions by x plus 3, x minus 3. Mm-hmm. So I just want to make sure I've got your question correct. If this was just x minus 9, then we would have to have x minus 9, x plus 3, x minus 3 over there. We would have to have all of them. Yes. It's only because I factor this, and the two factors in this denominator are exactly the same as these factors here. That's why I don't need to write them down again. Did you have a question, Mohammed? Yep, bathroom passes right over there. On my first rational term, will anything cancel?
Both.
Both. So I'm not going to have anything to multiply by here. I just have that 2x left over. Plus, will anything cancel on the second rational term?
X plus 3.
X plus 3s are going to cancel. So I still have 3, and then in parentheses, x minus 3. Drop my equal sign down. What next?
X minus 3.
X minus 3 is going to cancel. And I'm going to multiply 1 times x plus 3. Do I really need the 1 there?
No.
No. As you move from left to right across this equation, do I need to do anything with this right now?
No.
Nope. What about here? Distribute, yes. All right, so I have 2x plus 3x minus 9. Drop my equal sign. What should I do back here?
Double distribute as well.
Double distribute?
Just distribute.
Just distribute. We double distribute when there's two terms to distribute back to something else. It's just going to be x plus 3, right?
Twice. There's my reason as to why it's double distribute. How about that?
You're like, we already distributed once in this problem. Combine my like terms together. What are my like terms? 2x plus 3x. And so when I combine those, I get what? 5x minus 9 equals x plus 3. What do I do after that? I can plus 3 on both sides. Or plus 3? Sorry. Plus 9. My apologies. So we're going to plus 9 on both sides. So I have 5x equals x plus what? 12. Minus x on both sides. What is 5x minus x? So 4x equals 12. Not minus. We're going to divide. We want to isolate the x, so it's the 4 that I need to get rid of right now, because the only thing over there other than the x is that 4. X equals 3. Am I done? What are we checking? Yep, make sure your denominator does not equal 0. So we had x squared minus 9 + 2x + 3. 2x + 3x = 9. 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 2x + 3x = We had x plus 3 and x minus 3. If I put 3 in a spot for an x, will it make any of these turn into a 0?
Yeah.
Yeah, how many of them? 2 of them, actually. All I care is that it makes one of them a 0. That's enough for me to throw it out. But if you look at it right here, 3 minus 3 equals 0. That's no bueno. It also does it to this one over here, because 3 squared is what? This would be 9 minus 9, which equals 0. Don't want that. So I have to throw this out. But that was my only answer. What'd you say? No solution. No solution. Nice work. Nice work, nice work. Let's do one more. Let's go look at number 3. We'll keep practicing with these tomorrow, by the way. Look at this first denominator with me. Does it have a GCF? Can I factor it? Speak up. I like that thought process that I just heard. So Jayon said this looks like a difference of 2 squares because we only have A and C. But then he goes, oh, wait, what's in between them? A plus sign. In a difference of 2 squares, what do you have to have between them? Have to have a minus. This is not going to factor for us. It is a stubborn mule. Since it does not factor at all, is this a multiple of that? Is 2x plus 4 a multiple of x squared plus 1? No. So I'm going to write down my LCD. What do I need to include in my LCD? Yep, I need to include both of the denominators, x squared plus 1 and 2x plus 4. I know there's a GCF in the 2x plus 4, but it was the only other denominator. Yes, ma'am?
What is that LCD?
LCD stands for least common denominator. Good question. I just realized as you asked that I hadn't actually addressed what LCD was. It is our least common denominator, and it's how we clear out our fractions. All right, so I'm going to multiply the first one by x squared plus 1 and 2x plus 4. Do the same thing over here, times x squared plus 1 times 2x plus 4. What's going to cancel on my first one? X squared plus 1. And so I just have 2x plus 4 left. Technically, I need to distribute a 1 to it. But if I distribute a 1 to it, end up with the same thing. What cancels on my second expression? 2x plus 4 cancels. So I still have the 3, and I have x squared plus 1. What should I do next? Distribute that 3. All right, so 2x plus 4 equals 3x squared plus 3. What kind of equation are we looking at here? Quadratic. Whenever you see that x squared there, that means it is quadratic. Since it has an equal sign, the first thing I need to do with a quadratic is what? Set it equal to 0. How do I get this equal to 0? Minus 2x minus 4. If you do it to one side, got to do it to the other side. Minus 2x minus 4. So on the left, I get the 0 just like I wanted. Will the 3x squared combine with anything?
No.
So I just recopy it, 3x squared. Does the minus 2x combine with anything? Nope, that's my b term. That is not a like term with my 3x squared.
9.
Yep, 3 minus 4, I get a negative 1. What do I need to do now? Do the x. We don't have a GCF. Nice job looking for that. All right, thank you, dear. We're going to multiply a and c together. What do I get when I multiply a and c together?
Negative 3.
-3. What's my b value? What multiplies to give me -3? I heard -3 and 1. Does that add to -2? Yeah. B value's negative, so the bigger number has to be negative. So
Now
here's
do
the
the
two
box.
numbers. Now we do our box, our area model. Remember, A goes in the upper left, C goes in the lower right. So 3x squared, -1. What do I do with the -3 and the 1 when I put them in my area model? Put x's back on them. So I have a 1x and a -3x. Does not matter which of those boxes you put it in. What can I take out of 3x squared and 1x? I can just take an x out. What about -3x and -1? -1. 3x squared and -3x? I can take a 3 out. Anything else? An x. What about 1x and -1? Positive or negative? Positive. What do I do with each of those now? Set them equal to 0. X minus 1 equals 0. 3x plus 1 equals 0. So I'm going to add 1 to both sides. One value for x is what? -1. Positive 1 or -1? Positive 1, because we added 1 to both sides. That's okay. I messed up royally earlier with a sign, so we're all good.
Looking like never-ending fractions.
Right? Will this make either one of my denominators a 0? Well, let's check. X squared plus 1. If I put a 1 in here, and then I square it and add 1, what do I get? That's 2, right? Because 1 squared is 1. I'm good with that, right? What about the other denominator? Will it make that one a 0?
Doesn't even affect it at all.
Yeah, 2 times 1 plus 4, that is not 0, which is really all I care about. Is it 0? All right, so let's go to the other one. I'm going to subtract 1 from both sides. I get 3x equals -1.
Divide 3.
Divide both sides by 3, and x is?
-0.33 repeating.
Or my preference would be to leave that kind as a fraction, so -1/3. You're right, as a decimal, it's -0.3 repeating. Will this make either one of my denominators a 0? No. If I square -1/3, it's not going to become a -1. Oops, I wrote half. That's not equal to 0. 2 times -1/3 plus 4 is not equal to 0. So we are good with both of these answers. All right. Don't forget, guys, you have homework due on Friday morning. We will continue to practice tomorrow. We're going to do these other 3 problems on the page. And then Friday, Monday, and Tuesday, we will review for your test. Test is a week from today. One other announcement. 1 month from today. 1 month from today, May 13th. That's the Friday before the last full week of school. That is when all of the assignments in Canvas will close and lock. because I have to have time to finalize grades before we get into the exam, okay? If you have any later missing work or you'd like to retry an assignment because you want to increase your score, you have exactly 1 month from today. That also goes for corrections and retakes on tests, all right? So if you guys were thinking, yeah, I want to do that, but you haven't gotten around to it yet, the timer is now running. I just want to make you guys aware of that, all right?